to see this a lot in this class. It plays an important role in calculus, especially when we get to talking about things called derivatives, which we'll learn more about in the upcoming units. Okay? All right. So that is the composition of function stuff that I wanted to talk about here. Now what we're going to do is we're going to talk a little bit about how some of these compositions or additions and subtractions and multiplication things, what kind of effects these different operations have on graphs of functions. Okay? So let's see, shifts, reflections, and scalings on graphs. And again, hopefully some of this stuff is reminiscent of material you've seen before. If not, this will be a somewhat quick overview, but hopefully we'll get the main parts down. So, in working with graphs of functions, there's lots of different things we can do. So if we take a simple example of a function, and we use a linear function just to make things, we use a quadratic function to start with just because the linear ones don't necessarily show what I want to show you. Let's take a look at the function x squared. Okay. We've seen this function earlier today. We know what the graph of this particular function looks like. The graph of this function is a nice U shape opening up. Okay, so there's our graph. Y equals x squared. All right. Now, suppose I wanted to take this exact graph and I wanted to shift it up. How could I change my function of f of x to take this exact picture and just move it up a couple units? What could I do? Just add some value to it, right? If I want everything to be shifted up, well, then just add the same number to all of the points in the graph, and that's going to shift your whole graph up. So if I want to make a vertical shift in my graph, say I want it to go up, all I'm going to do is add k to f of x. Right? The k that I'm adding is exactly how much I'm going to shift that graph vertically. Okay? So if k is positive, as this one indicates, this will shift up k units. If I want it to go down, it will shift down that same number of units. All right, so moving up and down, check. Easy enough to do, right? Add or subtract numbers to all of our points. All right, that's our vertical shifts. Now we have to worry about what if I want to shift it left and right. Moving this graph to the left or to the right. How do I do that? How do I make that change to my function to get it to move, say, 3 units to the left or 2 units to the right? Well, this is a little different. This is one of those things that we're changing by shifting it to the left and right. We're actually changing the inputs to our function. Okay? If, for example, I want this vertex to be over here at x equals -1. Well, then what I'm doing is I'm now saying that when I plug 1 or -1 into my function, I want it to give me 0 out. Okay? I'm shifting all of the points to be different. They're coming earlier than they would have usually have come in our original graph. So horizontal shifts. These are changes in our input.